Worker egg. Your life starts as a single egg smaller than a grain of rice, laid by the queen in a wax cell so perfect it could have been measured with engineering tools. The queen can lay up to 2,000 eggs a day in peak season, and each one is placed with precision. Whether you become a worker or a queen depends less on destiny and more on food. Same genetics, different nutrition. If you are fed royal jelly for life, you become royalty. If not, welcome to labor. As a worker egg, you spend about 3 days in silence while your body blueprint begins unfolding. Temperature around the brood must stay near 35 degrees Celsius, and the colony works non-stop to maintain it by vibrating flight muscles like tiny heaters. If temperature drops, development slows. If it spikes, embryos can die. Every worker around you is already investing energy into your survival before you even hatch. You are not an individual yet. You are an incoming unit in a superorganism. Your future role will shift many times, but from this first stage, one truth is already set. You were born female, and you were born to work until you die. Larva. On day 4, your egg hatches into a larva. You look nothing like a bee. No wings, no eyes, no legs. Just a white curled body with one job. Eat. Nurse bees feed you constantly, up to 1,300 times a day, delivering pollen, nectar, and glandular secretions rich in proteins and lipids. In just 6 days, you increase your body mass by more than 1,000 times. That's one of the fastest growth rates in the insect world. You never leave your cell. You float in food and convert energy into tissue at astonishing speed. During this phase, your future caste is locked in. Worker larvae get a shorter dose of royal jelly, then transition to worker diet. Queen larvae remain on royal jelly continuously, triggering massive physiological differences, larger body, developed ovaries, extended lifespan, same DNA, radically different outcome. Around day 9, nurse bees cap your cell with porous wax. Inside, you spin a cocoon and prepare for metamorphosis. Larval life is pure consumption and transformation. You are fed by a society designed for efficiency, and every bite is an investment in future labor power. Nurse bee. You emerge as an adult worker around day 21, soft-bodied and pale, and your first major assignment is nursing. At this age, your hypopharyngeal glands are at peak output, producing brood food and royal jelly for larvae and the queen. You become part of the colony's biological maternity ward. You inspect larvae, feed them, monitor moisture levels, and regulate brood temperature with your own body heat. If brood chills, development fails. If food quality drops, future workers emerge weaker. You are responsible for the next generation's survival and quality control. Nurse bees also groom newly emerged workers, remove contaminants, and distribute antimicrobial compounds that help suppress disease. You feed the queen directly, and through this contact you spread her pheromones, chemical signals that maintain social order and suppress worker reproduction. In high brood periods, your workload is relentless, one feeding trip after another, thousands per day. Mistakes cost colony strength. A poorly fed larva can become an inefficient worker. At this stage, your value is not in flight range or combat ability. Your value is developmental precision. You are shaping the colony's workforce before it even has wings. Builder bee. As your glands shift from brood food production to wax secretion, your role changes. Now you are a builder. Wax scales exude from glands on your abdomen as thin translucent plates. You chew and warm them until pliable, then mold them into hexagonal cells with geometric accuracy humans still study in engineering and material science. Hexagons maximize storage with minimal material, nothing wasted. You help expand brood chambers, reinforce honey storage, and repair structural damage from heat, moisture, or intruders. During nectar surges, construction accelerates because storage demand spikes fast. A strong colony can build thousands of cells in days. Comb orientation matters too. Cell angle is slightly tilted to keep nectar from spilling before it thickens into honey. Temperature control during construction is critical. Wax softens around 40 degrees Celsius, so teams of workers cluster and ventilate to keep build conditions stable. Builder bees also adjust architecture in response to colony needs. Brood area near thermal center, honey hire, pollen near brood. It's modular urban planning done by insects with brains the size of sesame seeds. At this rank, you are not gathering resources, you are building the infrastructure that keeps the entire superorganism operational. Cleaner bee. Before larvae can be raised, cells must be spotless. That's your job as a cleaner bee. You inspect brood cells one by one, removing leftover cocoons, fecal traces, pollen dust, mold spores, and microbial debris. A queen will not lay in a dirty cell. No clean cell means no egg. No egg means no worker. Colony growth can stall from sanitation failure alone. You also groom nestmates, removing mites, spores, and contaminants from body hairs and joints. The social hygiene is a frontline immune defense. Honeybees practice what researchers call social immunity, collective behaviors that reduce disease spread before pathogens gain momentum. Cleaner bees detect abnormal brood odors and can trigger hygienic removal of infected larvae, including those affected by chalk brood or foul brood. You help polish wax surfaces with antimicrobial secretions and redistribute propolis-like substances where needed. It is repetitive, meticulous work with no glamour and huge consequences. In dense colonies, one neglected contamination zone can amplify infection rapidly. At this stage, your contribution is microbial warfare through discipline. You are the janitor, infection control officer, and preventive medicine team rolled into one six-legged unit. Guard bee. Now you move to the entrance, one of the most dangerous posts in the hive. As a guard bee, you screen every incoming bee and challenge anything that smells wrong. Colony identity is chemical. If a returning bee carries unfamiliar cuticular hydrocarbons, you block entry, grapple, or sting. Robber bees from nearby colonies attempt infiltration during nectar shortages, and if they breach, they can strip honey stores and trigger colony collapse. Wasps, hornets, ants, and mammals also test the perimeter. You sound alarm pheromones when threatened, releasing isoamyl acetate, the same banana-like scent beekeepers recognize during defensive events. One guard's alarm can recruit dozens instantly. You can overheat intruders, too. Against some hornets, workers swarm and raise temperature around the attacker beyond lethal thresholds. Guards also regulate traffic flow, reducing congestion during peak forager returns. In cooler weather, you help reduce airflow loss by narrowing entrance activity. Your risk is extreme. Sting once into mammalian skin and you likely die from abdominal rupture. Yet the colony is worth more than one body. At this rank, your life becomes perimeter defense. You are the hive's immune response with a stinger. Undertaker Bee. Death management is a full-time task in a healthy colony, and you become one of the workers responsible for it. Undertaker bees locate dead adults, failed brood, and biologically hazardous material, then remove it from the hive as fast as possible. Corzes inside a warm, humid nest are disease bombs. Bacteria and fungi can bloom quickly, threatening brood and food stores. You detect death through chemical change, decomposition odor profiles, and reduced movement cues, then drag bodies to the entrance and dump them away from traffic zones. In severe cases, colonies perform social fever, elevating hive temperature to suppress pathogens, while undertakers accelerate corpse removal. If pupae die in capped cells, hygienic workers uncapped and extract remains to prevent foul brood spread. This is harsh but necessary. Some bees die during removal from pathogen exposure or predator attacks near discard zones, yet the behavior persists because colony-level survival depends on strict sanitation. Undertaker work highlights the superorganism logic of honeybees. Individual death is expected, managed, and integrated into system maintenance. At this stage, your rank is grim but essential. You keep the hive from turning into its own epidemic source. Food processor bee. Raw nectar is unstable. It ferments easily, absorbs moisture, and spoils fast. As a food processor bee, you help convert that vulnerable liquid into shelf-stable honey. Returning foragers transfer nectar mouth to mouth through trophallaxis, and you receive it for enzymatic treatment. Invertase breaks sucrose into glucose and fructose. Glucose oxidase generates antimicrobial hydrogen peroxide and gluconic acid. You then deposit thin nectar films into cells and fan your wings to accelerate evaporation. Fresh nectar may contain 60 to 80% water. Honey must drop to around 17 to 18% water to resist fermentation. That concentration process is labor-intensive and collective. Processor bees also pack pollen into cells, mix it with enzymes and microbes, and create bee bread, a fermented protein source for brood rearing. Storage placement matters. Pollen near brood, honey in upper comb zones. During major flows, processing bottlenecks can limit colony intake more than field collection does. Your role is biochemical manufacturing, quality control, and inventory stabilization. You are running a decentralized food refinery inside a wax city. Without this step, the colony starves in winter, no matter how much nectar foragers bring home. Scout Bee. When resources shift, old maps become useless. That's where Scout Bees take over. As a scout, you leave the hive without guaranteed reward and search unknown territory for nectar, pollen, water, and potential nest sites. Risk is high. You may fly kilometers and return empty. But one good discovery can feed tens of thousands. Once you locate a rich source, you return and perform the waggle dance, encoding direction relative to sun angle, distance through waggle duration, and quality through dance vigor. Other bees evaluate your signal and decide whether to follow. This is distributed decision-making in real time. Multiple scouts advertise competing sites, and recruitment dynamics determine which source wins labor allocation. During swarming, scout behavior becomes even more critical. Scouts inspect cavity volume, entrance size, height, and microclimate, then campaign for preferred sites through repeated dances. Colonies can reach consensus without central command. In effect, you are part explorer, part data transmitter, part democratic voting mechanism. Scout intelligence is collective intelligence expressed through movement and vibration. At this rank, you trade certainty for strategic advantage. You are the colony's search engine and expansion planner. Forager Bee. This is your final and most dangerous worker role. As a forager, you leave the hive daily to collect nectar, pollen, water, and plant resins. You navigate using sun position, polarized light, landmarks, and internal circadian timing. On productive days, you can make 10 to 15 trips and visit thousands of flowers. Each trip costs energy and increases mortality risk. Predators, weather shifts, vehicle strikes, pesticides, and wingwear all take a toll. Foragers are older workers and biologically expendable compared to in-hive specialists. Yet colony survival depends on your throughput. Nectar fuels carbohydrates, pollen supplies proteins and lipids for brood. Water enables cooling through evaporative fanning. Propolis resins reinforce antimicrobial defense. You also carry ecological power beyond the hive. Pollination by foragers supports wild plant reproduction and large fractions of human agriculture. Almonds, apples, berries, cucurbits, countless systems rely on this labor. Communication continues at home through dances that redirect workforce to best blooms. You are supply chain logistics and ecosystem engineer at once. Most foragers die outside the hive. You leave, work, and often never return. But your labor keeps the colony alive. Drone. If you hatch from an unfertilized egg, you become a drone. Male, larger-eyed, thicker-bodied, and built almost entirely for mating. You have no stinger, do not forage, do not build comb, and do not defend the hive. Your primary biological mission is to mate with a virgin queen during nuptial flights. Drone eyes are massive because aerial mating requires rapid visual tracking at speed. In drone congregation areas, thousands of males from multiple colonies gather in predictable airspace corridors. A queen may mate with 10 to 20 drones in one flight sequence, storing sperm for years. If you succeed, mating is terminal. Your endophallus everts explosively, detaches, and you die immediately. If you fail and return to the hive, workers feed you during resource-rich seasons. But when nectar drops, drones become liabilities. Workers stop feeding them, drag them out, and prevent reentry. This drone eviction can kill entire male cohorts before winter. Harsh, but efficient. Drone life is a gamble with one high-stakes objective and no fallback plan. You either pass genes forward in one instant, or you are removed when resources tighten. Queen. If fed royal jelly continuously as a larva, you become queen. Same genome as workers, completely different physiology. You emerge larger, sexually mature, and capable of laying up to 2,000 eggs per day in peak season. After mating flights, you store sperm in a spermatheca and use it for years, deciding egg by egg whether to fertilize. Fertilized eggs become females, unfertilized eggs become drones. Your pheromones regulate colony behavior, suppress worker ovary development, coordinate social cohesion, and signal reproductive status. You do not rule through thought. You regulate through chemistry. The colony can replace you if your pheromone output declines, your laying pattern becomes inconsistent, or disease compromises performance. Workers then raise emergency queens from young larvae. During swarming, old queens depart with part of the workforce, while new queens emerge and may duel to the death for succession. Queen lifespan can reach 3 to 5 years, far beyond worker lifespan measured in weeks. You are both individual and reproductive organ of the superorganism. Your survival matters, but colony continuity matters more. In bee society, even a queen is replaceable if system efficiency demands it.